Sure. Let us try to do some numericals better based upon your loss and as well as if it transfers vibration conditions. Okay, na? Sure. See the first question there, beta. Say for example, the length of a sonometer. I'll tell you what is a sonometer. Sonometer wire between two fixed ends. Between two fixed ends is 1.10 meter. Is 1.10 meter. Where should the two bridges be placed to divide the wire into three segments. The wire into three segments whose fundamental frequencies are in the ratio 1:2:3. Okay. Read the question carefully, better first there. We got a sonometer wire. The length of the sonometer wire is given for me how much better, which is been fixed at the two ends. It is given as of your 1.10 meter. 1.10 meter. So what is a sonometer? Ante instrument which is been something like this. This is your instrument beta. This is board on kunna. Okay. And here there is some pulley. And here a wire is been fixed on this one. From here to here, a wire is been fixed, which has been passing. And from here, it has been hanging down with a weight of M. This is the mass actually here, M. So tension developed in this one will be T. The weight of this one will be equal to M into G. And here this will be the tension T. Okay. The box, isn't it? Now there are the bridges being placed on this one. Bridges means right now supports. Idoko support. This supports by nunchi. This wire is been going. This are called as of your bridges. Okay. Now read the question there, beta. The length of the sonometer wire between the two fixed ends is 1.10. That means this one is the length between these two. Okay. So the length of the sonometer wire between the two fixed ends is 1.10 meter. Where should the two bridges be placed? These two bridges should be placed to divide the wire into three segments, so that I can divide this wire into three segments whose fundamental frequencies are in the ratio of, it should be in the ratio of 1:2:3 part of a relation. Okay. That means in between this one, we should get the three segment beta. In between this one, we should be getting how many segments beta? Three segments right now. That means there should be three loops which have been forming in this one. Is it clear? Is it clear?
Yes, sir.
ఈ క్వశ్చన్ అర్థమైందా? ఈ బ్రిడ్జెస్ మధ్యలో ఈ బ్రిడ్జ్ B1 ఈ బ్రిడ్జ్ B2 మధ్యలో త్రీ లూప్స్ ఫామ్ అవ్వాలా. And what should be the length of that one? They should be the ratio of what? 1:2:3. If they are 1:3:3, what part of relation is asking is, where should these two bridges should be kept? ఈ two bridges మధ్యలో డిస్టెన్స్ ఎంత అవ్వాలని అడుగుతున్నాడు basically. ఓకేనా? క్వశ్చన్ అర్థమైంది అందరికి?
Yes, sir.
So once again.
ఏనన్నా?
Once repeat again.
Yeah. See here, beta. The length of the sonometer wire between the two fixed ends is 1.10 meter. This is one bridge and this is one bridge. This is total setup is known as sonometer. This is a total wire which has been fixed at one end of the box and another end has been connected to the weight mg. More the weight, more will be the tension in this one. So it will become more tight. Now, if I'm fixing between these two bridges, the length between these two bridges is given how much for me, beta? 1.10 meter. Now, what I was asking is, where should the two bridges be placed? That means these two bridges should be placed at what distance so that the wire is in your three segments. The wire is forming into your three segments parts of your relation. Is that clear? Whose frequency should be in the ratio of what? 1:2:3. Okay. As it is forming three segments, see how I can write this relation. So total length should be equal to how much, beta? How many segments it is forming right now? Three segments. Three segments means I don't know the length of that one. So the length of the first loop might be L1. The length of the second loop might be L2. The length of the third loop might be your L3. That must be equal to total length of that one. That must be equal to 1.10 meter. Is that clear? So the first loop is say for example L1. Second loop is say for example L2. And third loop is say for example of your L3. Okay. That means three loops are been forming between these two bridges like this. 1, 2, 3 like this. Three loops have been forming in this. This is your L1, this is your L2, this is your L3. And here there are the bridges. And here there are your bridges. The total length is already given how much for me? L. L is equal to how much for me? 1.10. So L1 plus L2 plus L3 must be equal to how much? 1.10. The frequency of this one is given for me how much, better? For sonometer wire, frequency is F is equals to your 1 by 2 into your L under root of your T by mu. Formula gurtunda? Or N కూడా రాసుకోవచ్చు. Frequency small n తో represent చేసుకోవచ్చు or n తో represent చేసుకోవచ్చు. So F is equal to 1 by 2L under root of your T by mu. Is that formula clear for everyone? Now చూడండి, this mass is right now for me constant. So tension developed in the wire will become for me constant. If the tension is right now constant, so T is right now for me or constant. Mass per unit length, that is mu is also equal to your constant. Because length of the wire is not going to change. Total length is always remaining for me same. Mass of that one is also remaining same. So mass per unit length is also constant. So T is constant, mu is constant, F2 is also constant. So frequency is inversely proportional to what, beta? Length. First law I'm using right now. That means F into your L will be equal to how much, beta? F into your L is equals to your constant. Can I write like this? Given in the problem, F1 is to, F2 is to, F3 is given as of your 1:2, 2:3. That means F1 is equal to how much, beta? F. F2 is equal to how much, beta? 2 times of your F. And F3 is equal to how much, beta? 3 times of your F. Isn't it? Okay, na?
Yes,
This
sir.
is good. So I can write here right now. F1 L1 is equals to your F2 L2 is equals to your F3 L3 is equals to some constant that is nothing but F your K. So therefore I can write from the given relation right now. L1 and L2 will be equal to how much, beta? L1 will be equal to your K by your F1. F1 is how much for me? F. L2 will become for me your K by your F2. F2 is nothing but 2 times of your F. L3 will become how much for me, beta? L3 is equals to your K by your 3 times of your F. Okay, na? I got the values of L1, L2, L3 in terms of your constant and as well as of your frequency. Is it clear?
Yes, sir.
Yes,
Now,
sir.
we know L1 plus L2 plus L3 is how much? Say, for example, this is equation number 1. And this is all equation number 3. So what you do is, now using equation 1. So what is in equation 1 right now, beta? L1 value is equal to how much for me, beta? K by your F plus of your K by your 2F plus of your K by your 3F must be equal to your, how much it will be become, beta? What is the value given for me? 1.10. That means I can take 1.1. So in this one, K by F will be common. So K by F is a common. So this will be equal to 1 plus, this will be 1 by 2 plus 1 by 3. Isn't it? So that is equal to how much, beta? 1.1. అంతేనా? ఈ వాల్యూ మొత్తం ఎంత అవుతుంది చూడండి. 1 plus 1 by 2 plus 1 by 3 is how much, beta? K into your F into LCM will become for me 6. That will be equal to 4, 5, 6. That means 11 by 6. That is equals to 1.1. Antena?
Yes, sir.
So K by F value enta avutundana? K by F will become how much for me? 1.1 means 11 by 10. 11 by 10 means 11, 11 వెళ్ళిపోతుంది, 6 ఇక్కడ వెళ్ళిపోతుంది, 6 by 10. 6 by 10 is nothing but equal to your 0.6. Okay, na?
Yes, sir.
So therefore, L1 must be equal to how much better? K by your F. That is equals to your how much for me? 0.6 meter. L2 must be equal to how much better? K by 2 times of your F. That means that will be equal to how much?
0.3.
Value is 0.6 divided by 2. That will be equal to 0.3 meters. And L3 will be equal to how much for me? K by your 3 times of your.
0.2.
So this will be equal to 0.2. This one is 0.6 divided by 3. This will be 0.2 meters. So the bridges must be placed at what distance better? L1 is equals to your 0.6 meter and L1 plus L2 must be equal to 0.9 meter from the left end. Then, that means if I'm forming like this is a point. The first one is 0.6 more. That means it should be larger like this. This will be one loop. The next one is little bit of your smaller loop. And third one will be this loop. Okay. So this will be equal to how much? 0.6 meter. This will be equal to 0.3 meter. And this will be equal to 0.2 meter. The distance between these two. The distance between these two. The distance between these two. So this is your left hand. And this is your right. Okay. So from left hand, L1 is equals to 0.6 meter. L2 will be equal to 0.6 plus 0.3. That will be equal to 0.9 meter. L3 will be equal to how much better? 0.6 plus 0.3 plus 0.2. How much? 1.1. Got it? Student, Malasa student. What you are doing the problem right now? The length of the sonometer wire from between the two fixed ends is given as 1.10 meter. Where should the two bridges should be kept is asking. So the two bridges should be kept between right now how much point of relation beta? So they should be kept at a distance. The bridges should be kept at a distance of L1 is equal to your 0.6 meter and L2 must be equal to your how much beta? 0.9 meters part of relation. So then we'll be forming how many bridges right now? 3 segments will be formed right now. Clear?
Yes, sir.
అర్థమైంది అందరికి మరోసారి చెప్పనా ఇదంతా క్యాల్కులేషన్ పార్టే ఓకే నెక్స్ట్ వన్ very important model, so try to listen this carefully. If you are having any doubt, you please let me know. Say for example, here you see the figure shows a string the string vibrates in its 10th harmonic in unison a beaker containing water is brought under the block so that the block is completely dipped into the beaker. Okay. The string vibrates. The string vibrates in its 11th harmonic. 11th harmonic. Find the density of material. Find the density of the material of the block. Density of the material of the block. I'll give the diagram for this one.
Sir, answer your question, sir.
Yeah, I'll show you. Sure. See this question better once again. Figure shows a string which has been stretched by a block going over a pulley. This is a string passing through the pulley connected to the block. The string vibrates in its 10th harmonic. The string is vibrating in how many harmonics, beta? 10th harmonic in unison. Unison means same. What do you mean by unison? Unison means same. The frequency of the first one and second one, if they are same, that is known as of your unison. Unison with a particular tuning fork. With a particular tuning fork, when a beaker containing water is brought under the water, so that the block is completely dipped into the water, the string vibrates in the how much mode, beta? 11th mode. Find the density of the material of the block. Now see, దీనిపైన vibrations దేని వల్ల వస్తున్నాయి నాన్న? దీనిపైన vibrations are coming because I'm taking a tuning fork and keeping it here, and this tuning fork has been hit to some hard surface so that it is producing the vibrations like this. Because of these vibrations, a wave is being developed in this one, and this wave is being going along the string like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. So how many totally? 10, isn't it? So now whatever the frequency have been developed in this one, this is equal to the frequency of the tuning fork, right? See what is telling? The figure shows the string which has been stretched by a block going over a pulley. The string vibrates in the 10th harmonic. The string vibrates in what, beta? 10th harmonic, and it is unison with the particular tuning fork. That means the frequency of this wave is equal to the frequency of this tuning fork. Okay, now. So when a beaker containing water is brought under the block, now when this is in the air, this was how many having vibrations? 10 modes. When this is being brought into the water, then we are getting 11th mode. Then find the density of this material of the block is asking. Okay. So first I'm writing here, beta. This is the total length of the string. And how many loops are there in this, beta? 10 loops. How many loops are there right now? 10 loops. Weight of this body will be equal to how much, beta? Mg in the downward direction. And tension in this one is nothing but equal to capital T. Okay. So frequency, how do you write, beta? Frequency is equals to, this is standard formula, P by 2L. So this will be equal to P loops divided by 2L under root of your T by your mu. How many loops are there? 10 loops. So this will be equal to 10 by 2L under root of your T by your mass per unit length. So this is my equation number 1. This is the frequency. Is it clear up to here?
Yes,
Okay, now.
sir.
Okay. Now here tension T will be equal to how much, beta? AM into G, because it is in the air. Now see what you do is the same thing is right now immersed in the water now. It is immersed in the water. Now this is your part here right now. And this is your pulley right now here. And The string has been passing through this one like this again. The block has been attached to this. And it is fixed here right now. This string is also fixed here right now. Okay. Now below there is a beaker now. This one. And water is being filled in this one, and it is completely immersed in the water like this. Okay, now tell me, this is the mass of your ear. What are the forces acting on this body? Can anyone tell me, beta? One is the weight of this body. It is acting in the
Buoyancy
force.
Yeah, tension in the string will be equal to T. And along with that one, buoyancy force is acting in the upward direction. That is nothing but of your FP, buoyant force or upthrust is acting in the upward direction. So here also there will be the tension T. Here also there will be the tension T. And here also there will be the tension T. When it is immersed in the water, how many vibrations it was been making, beta? How many loops? 11 loops. So this one is of your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, something like that. So orally I'm writing here right now. These are how many loops right now for me? 11 loops. Okay. So this will be the length of this. Water, when it is not in the water, it was having 10 loops. When it is immersed in the water, now it is giving me how many loops, beta? 11 loops for the given condition. Now simplify this relation better. The tension, will it be same or change? It will be changing. So that will become for me T dash plus of your buoyant force will be upward direction. That must be equal to weight of the body in the downward direction. So T dash will be equal to your how much, beta? Your mg minus of your buoyant force. So that will be equal to your m into g minus buoyant force will be equal to how much, beta? M dash m into your g. Mass of the body in the water. So m into g is minus mass is equals to how much, beta? Mass is equals to volume into your density of your body part affiliation. Is that clear? Is that clear?
Yes, sir.
Yes, sir.
So I can write here mass is equals to your volume into your density. Density of what? Water. This volume will be equal to how much, beta? Volume will be equal to your mass of the body divided by, because mass is equals to your how much for me? Mass is equals to volume into density of body, isn't it? So volume is equals to how much I can write? Mass by your density of the body into density of water. Can I write like this? See, this m dash is nothing but what? It is the weight of the liquid which has been displaced when this amount of the block is immersed in the water. So m dash is equals to volume displaced into density of water. Volume displaced is because of this weight of the body. That is the reason I'm writing the volume of the body. So volume of the body means mass of the body is m divided by density of the body into density of a liquid. So that value I'm writing here. So m dash value will come for me as of your m into your density of water divided by density of body into your g. Can I take anything common in this one, beta? mg and mg I can take common here right now. So this will be equal to your mg into 1 minus density of water divided by density of your body. So this will be the tension T dash. Okay now?
Yes, sir.
Isn't it? Rho W is the density of water. Rho B is nothing but the density of your body. Is it clear?
Yes, sir.
Yes, sir.
Now frequency, you write the answer for this one, beta. So frequency for this one is how much for me, beta? F is equals to how many loops? 11 loops. So 11 by 2L under root of your T dash divided by me. Frequency is also becoming for me F dash. So this F dash will be equal to your how much for me? 11 by 2L under root of your T dash value. How much we got right now here? mg into 1 minus density of water divided by density of body divided by linear mass density mu. Okay now? Clear up to here?
Yes, sir.
So you got the frequency in the air, you got the frequency in the water. I hope you are clear up to this one, everyone.
Yes, sir.
Chalo,
Yes, sir.
Mala sir, question. Figure shows the string stretched by a block going over a pulley. The string vibrates in the 10th harmonic. First one we have already take the 10th harmonic, and it is in unison. What do you mean by unison, beta? The frequency of the 10th loop must be equal to the frequency of the 11th loop. With a particular tuning fork, when a beaker containing water is brought under water so that the block is completely immersed into the water. as they are in unison, I can write as they are in unison. Unison means same. Unison. F must be equal to your F dash. Okay, now F value is how much for me? 10 by your 2L under root of your, this will become for me mg divided by your mu. That is equals to, this one is 11 by 2L under root of your, this will become for me your mg into your minus density of water divided by density of body divided by your mu. Anything is getting cancelled in this one, you see better. This 2L get cancelled, this mg will get cancelled, this mu and this mu also will get cancelled. So ultimately remaining value I can write here. This one is equals to 10, that is equals to 11. So that is equals to 11. This will be under root of your 1 minus density of water divided by density of body, isn't it? So if I remove this one, 1 minus density of water divided by density of your body will be equal to, this will become how much better? 10 by 11 to the power of your 2. Antena? So that will become for me 10 square. 10 square value is nothing but equal to 100. 11 square is nothing but equal to 121. So I can write here density of water divided by density of your body is equals to your 1 minus 100 divided by 121. That means that will be equal to how much better? LCM is nothing but 121. 21 minus 100, that will be equal to 21. So 21 divided by 121. Okay, now. So density of the body will become how much better? Density of the body will become for me 121 divided by your 21 into density of your water. Clear? As
Yes, sir.
density of water is equal to how much better? 1 gram per cc. So therefore I can write density of your body will be equal to your 121 divided by your 21. So that will be equal to your how much? Can anyone tell me? Entalo bothund? 5.8 gram per cc. So density of the body will be equal to 5.8 gram per cc. This will be the density of the body. Is it clear?
Yes, sir.
Yes, sir.
అర్థమైంది అందరికి ఇక్కడ వరకు?
Yes, sir.
వాయిస్ ఎవరు మాట్లాడడం లేదు, ఏమైంది? ఉన్నారా, నిద్రపోతున్నారా? So the next question, better. If the tension and diameter of a sonometer wire of fundamental frequency F are doubled and density is half, then its fundamental frequency will become dash. Give the options. F by 4, root 2 into your F, third one is F, fourth one is F by your root. So read the question right now. What is the question we got right now there, beta? If the tension and the diameter of the sonometer wire, sonometer, I just draw the diagram. How do you represent it right now? So what is telling? Vibrates in a fundamental frequency F. So if the tension and diameter of the if the tension and diameter of the sonometer wire of fundamental frequency F are now doubled and density is half, isn't it? So then the fundamental frequency will become how much per meter? So fundamental frequency formula will be equal to how much beta? F is equals to 1 by 2L under root of your T by your mu. Can I write the mu in terms of your density beta? Isn't it? Because mu is equals to how much beta? Mass per your unit length. Mass is equals to volume into density divided by your L. Volume is equals to area into length into density divided by L. LL gets cancelled. So it is area into rho. Area can be written as of your pi r square into your density. So the frequency can be written as 1 by 2 into your L under root of your, this will be equal to T divided by mu is equals to how much I'm writing? Pi r square into rho. So this is the frequency formula in terms of your density. Okay. Is it clear? Now write the frequency of this one beta. F2 divided by your F1 will be equal to your under root of, this will become for me 1 by 12, 1 by 12 will get cancelled. So this will become for me T2 divided by T1 into, this will become for me rho 1 divided by rho 2 into your, this one will become for me your R1 divided by your R. And this one is right now how much for me? Whole square. Ante kada? So F2 divided by your, this one is given as of your F1 will be equal to your under root of your. Has it told anything about the tension beta? Fundamental frequency and density are been half. What about the tension?
Doubled, sir.
If the tension and diameter of the sonometer wire are doubled, that means this will become for me how much? T2 will become for me 2 times of T1 divided by your T1 into density of this one is rho 1. Rho 2 is nothing but half. That one is rho 1 divided by 2 into R1 is R. R2 is also doubled. That is nothing but of your 2R whole square. So anything is getting cancelled in this one beta. This T1, rho 1, R and R will get cancelled. So I can be writing right now F2 by your F1 is equals to, this one is under root of your, this one is nothing but 2 into, this one is nothing but of your 1 by 2. That means that will become for me 2 by 1 into, this one is nothing but of your 2 square, that is 1 by 4. This one will get cancelled. So therefore I can say that F2 is equals to F1, that will be equal to your F. Okay now? So what will be the answer for that one? Third option will be the answer. Clear beta?
Yes, sir.
Achinda?
Yes, sir.
Yes, sir.
I'm giving you now one simple question, you try to do it better, everyone. A guitar string is 90 centimeter long and has a fundamental frequency of 124 hertz. 124 hertz. Where should it be pressed? Where should it be pressed to produce a fundamental frequency? A fundamental frequency of 186 hertz. The guitar string is how much better? 90 centimeter long and has a fundamental frequency of your 124 hertz. 124 hertz. Where should it be pressed to produce the fundamental frequency of 186? What is the condition I can take, beta? Frequency and length is asking. So what is the relation between frequency and length, beta? F is equals to 1 by 2L under root of your T by your mu. Your mu is constant, T is a constant. So frequency is inversely proportional to the length. So I can write here right now for this given condition. So it is F into your L will be equal to your F dash into your L dash. Can I write like this, beta? Fundamental frequency is given how much for me? 124. Length of that one is given how much for me? 90 centimeter. Then to produce a fundamental frequency of 186, how much length is been required? That means L dash value is how much?
Sir, 60 centimeters.
How much? 60. 60 centimeters will be the answer. Clear? Okay, na?
Yes, sir.
అర్థమైందా
Yes,
మనకు?
sir. Clear, sir.
Next question. This one also try to do it. A stretched wire of length 110 centimeter, 110 centimeter is divided into three segments. Divided into three segments whose frequencies are in the ratio 1:2:3. To stop. Their lengths must be dash. First option is 20 centimeter, comma 30 centimeter, comma 60 centimeters. Second one is your 60 centimeter, comma 30 centimeter, comma 20 centimeter. And third one is 60 centimeter, comma 20 centimeter, comma 30 centimeter. And fourth one is your 30 centimeter, comma 60 centimeter, comma 20 centimeter. So read the question and try to do it better. I'm giving you 5 minutes of your time. So please try to do it out. The stretched wire of total length is how much for me, beta? 110 centimeter. Is divided into three segments whose frequencies are in the ratio of 1:2:3. Their lengths must be equal to how much? Just now I told you previous condition. Relation between frequency and length is what, beta? Inversely relation. Na? So you can use the relation N1 L1 is equals to your N2 L2 is equals to your N3 L3. Okay. So this has to be equal to some constant. That is nothing but equal to K. First frequency is given how much for me? N. Length is nothing but L1. Second frequency is double. That means 2 times of your N into L2. Next one is 3 times of your N into L3. That is equals to some constant, say K. So L1 will become
Option 2, sir.
option 2. Yeah, option 2 is correct answer, beta. Very good. So it is L1 will be equal to how much, beta? K by your N. Okay, na? And L2 will become how much, beta? K by your 2N. And L3 will become how much, beta? K by your 3N. Isn't it? So total length is given how much for me, beta? L1 plus L2 plus L3 is equals to has given me 110. That means this will become for me K by N plus of your K by 2N plus of your K by 3N is equals to your 110. Isn't it? So this means this total will become how much, beta? LCM will become for me 6N plus 6 plus 7 to 11. So this will be equal to your 11K by your 6N. That will be equal to your 110. So K by N will become how much, beta? 60. K by N is equals to 60. So once I know that one, therefore I can write here L1 is equals to your K by your M. That will be equal to how much beta? 60 centimeters. L2 will become how much for me beta? K by 2 times of your N. That means 60 divided by your 2. That will be equal to how much beta? 30 centimeters. And L3 will become how much beta? L3 is equals to your K by your 3 times of your N. That means that is 60 by your 3. That will be equal to your 20 centimeters. The answer must be equal to 60, 30, 20. 60, 30, 20. That means second option will be the answer. Okay, na?
Yes, sir.
You have any material with you to do the working beta?
No, sir.
No, sir.
Today I'll send you the assignment on the stationary waves and this topic beta. So you try to do it out, and whatever the problems you are getting, you try to do it. The remaining I'll try to help you out in the class. Okay, na?
Yes, sir.
So that by this we have been completed one part of the types of waves beta, that is formation of the stationary waves. We have been completed. We need to do the interference of waves and formation of waves bits. These two topics have been done. Then 3/4 of the syllabus will be completed. Still we are in this given condition, so we need to complete the syllabus a lot ahead. So we have completed the energy, we have completed the power part calculation. Then we need to go for the next one is about your interference of your waves part. Interference is nothing but again superposition. And finally, we'll try to go for the formation of your beats part relation. Okay, na?
Yes, sir.
Stationary waves పైన ఏమైనా ప్రాబ్లమ్స్ చేసాము మనం? చేయలేదు కదా? On my YouTube beta from today onwards, one more chapter I have been started, that is magnetism and matter. సెకండ్ ఇయర్ అది మీరు కూడా ఒకసారి గో త్రూ చూస్తుండండి నేను ఒకసారి వీడియో. సో సెకండ్ ఇయర్ లో ఇంకో చాప్టర్ కూడా మీకు ఓవరాల్ గా అయిపోతుంది ఒకసారి. సో టుడే ఓన్లీ ద ఫస్ట్ లెక్చర్ ఐఎమ్ అప్లోడింగ్ రైట్ నౌ. సో ఫ్రమ్ టుడే ఆన్వర్డ్స్ వన్ ద సెకండ్ ఇయర్ టాపిక్ దట్ ఈస్ magnetism and matter will be getting completed in another 10 days. నేను మళ్ళీ మీకు అది సార్ చెప్తాను, బట్ స్టిల్ ఈ టుడే నుంచి ఫస్ట్ డే వాస్ హ్యాపెండ్ ఎస్టర్డే నైట్. So you can just complete that from the YouTube channel today, so that you will get even the notes attached to that one. I'll regularly send the notes related to the magnetism and matter to you also. You can just read it out from the what you call the YouTube ones and try to go through the notes. అంటే ఇండైరెక్ట్ గా మీకు ఇంటికాడ కూర్చున్న చోటే ఒక చాప్టర్ అయిపోతుంది. సో మళ్ళీ మీకు టీచర్ చెప్పేటప్పుడు సార్ట్ ఆఫ్ రివిజన్ అయిపోతుంది క్లియర్ గా. ఓకేనా?
Yes, sir.
ఎస్సీ వర్మ చేస్తున్నారా, ఏమన్నా చదువుతున్నారా కనీసం? ఎస్సీ వర్మ కనీసం థియరీనే చదువుతుండండి అన్న రోజు. whenever you get the time, you at least try to give a study for your ఎస్సీ వర్మ notes. ఒకసారి చదువుతుంటే మీకు క్లారిటీ వస్తుంటుంది ఏం ఉందా ఏం లేదా అనేది బేసికల్. లూప్స్ దీంట్లో ఎట్లా ఫామ్ అవుతాయి నన్ను ఈ క్వశ్చన్ లో where should the two bridges should be kept ante from the sonometer wire. This is the point from the first one. This is L1, this is your L2, this is your L3. Ante if this is your wire right now and this is your another wire, this is your string, and here one bridge is being kept and here one bridge is being kept. In this one, the number of loops are been forming. From here to here, there is one loop like this. From here to here, there is one loop like this. And here to here, there is one loop like this. This is your L1, this is your L2, this is your L3. First loop should be at a distance of your L1. And second loop should be at a distance of your, how much for me, beta? L1 plus of your L2. So that it will form in the 3 loops. Okay, so this is your string. So the first bridge is kept here right now, and second bridge is being kept here right. That means first bridge is at what, beta? This is your first bridge. First bridge is kept at your 0.6 meter, and second bridge from the one end of the wire is being kept at 0.6 plus 0.3. That will be equal to 0.9. This is your second bridge. Okay. Problem. So by this, we have done almost all the transverse waves and stationary waves applications. We need to do some more good numericals better. Today, I'll send you the numericals on this one. So tomorrow also, we'll try to keep some time for the numericals, good numericals, and previous JEE mains, and as well as of your NEET questions. I'll try to do it out on this topic so that you will get an idea how the questions have been framed on the topic of your stationary waves. మీకు IP కూడా separate గా questions చెప్పాలా, మీరు చదువుకుంటారా నాన్న IP questions? ఐపీ డెరివేషన్స్ మీరు చేస్తారా? ఐపీ మెటీరియల్ ఉన్నాయి కదా మీ దగ్గర, లేకపోతే చెప్పాలా ఐపీ?
Sir, say sir.
ఐపీ ఇంపార్టెంట్ డెరివేషన్స్ నేను చెప్పేస్తాను, విచ్ ఆర్ ఇంపార్టెంట్ ఫర్ యువర్ కాంపిటేటివ్ ఎగ్జామినేషన్. వాట్ ఆల్ ఇంపార్టెంట్ క్వశ్చన్స్, ఆ డెరివేషన్స్ కూడా సార్ నీట్ గా చెప్పేస్తాను నేను. ఓకేనా?
Okay.
Yes, sir.
One long answer from this question beta. The weightage of this one is a long answer question. If you are completing this one, we are having 4 long answer questions in that one beta. The long answer questions నేను చెప్పేస్తాను. ఒక long answer question already మనం చేసాం. This is one of the long answer question. Law of transverse vibrations particle relation. Okay. ఇంకోటి డాప్లర్ ఎఫెక్ట్ ఉంది, అది ప్రస్తుతానికి అయితే డిలీట్ అయింది. మేబీ నెక్స్ట్ అకాడమిక్ ఇయర్ కూడా మీకు డిలీషన్ లోనే ఉంటుంది, అది 30% డిలీషన్ గా. సో అది చేస్తే విల్ బి హ్యావింగ్ ఓన్లీ 3 లాంగ్ ఆన్సర్ క్వశ్చన్స్ ఫర్ యువర్ బోర్డ్ ఎగ్జామినేషన్స్. దట్ ఇస్ ఓన్లీ ద వెయిటేజ్ ఫ్రమ్ దిస్ చాప్టర్. లాంగ్ ఆన్సర్ క్వశ్చన్, ఒక లాంగ్ ఆన్సర్ క్వశ్చన్స్ కంపల్సరీ ఫ్రమ్ దిస్ టాపిక్ బేసికలీ. ఓకే.
Yes, sir.
Yes, sir.
మీకు స్టేషనరీ వేవ్స్ ఎస్ఏ క్వశ్చన్ ఎలా రాయాలనేది కూడా నేను ఒకసారి చెప్తాను. సో ఒకసారి టుమారో ఐపీ అని స్పెసిఫికల్ గా మెన్షన్ చేసి హౌ టు రైట్ ద వే ఐఎమ్ రైటింగ్, యూ జస్ట్ రైట్ ఇట్ లైక్ దట్. ఆ ఎస్ఏ క్వశ్చన్ ఒకటి కంపల్సరీ అయిపోతుంది. ఇప్పటివరకు నేను చెప్పింది కంప్లీట్ ట్రాక్. ఒక 1 డే ఎప్పుడైనా టైం తీసుకొని దీనిపై దీన్ని లాంగ్ ఆన్సర్ గా ఎలా రాస్తారు అనేది కూడా నేను చెప్పేస్తాను. సో దట్ విల్ గెట్ ఎన్ ఐడియా. ఇఫ్ దేర్ ఈస్ ఎ లాంగ్ ఆన్సర్ క్వశ్చన్, యూ కెన్ డైరెక్ట్లీ రీడ్ ఇట్ అవుట్ ఫ్రమ్ దట్. ఓకే.
Yes, sir.
Take care, beta. If you have any doubts, you can talk to me. Boys, ఎవరు మాట్లాడడం లేదు. రామ్ సాయి, వసంత్, రమకాంత్, చరణ్ కుమార్ రెడ్డి, Abhinav. Don't have an option to unmute yourself. Jayant. Okay,
Sir,
Jayant. Beta.
law of transverse is
Law of transverse vibrations is pakka, sir, for IP.
Yeah, pakka. It is a damn sure question for your IP. There are 3 damn sure questions in that one. The one damn sure question we already done it. Tomorrow I'll tell you how to write it out, that question. Then we have one more closed pipe and organ pipes. If these 2 are been done, then one long answer question is completed.
Okay, sir.
okay, sir.
I'll tell you what to be studied in the IP also for this one. So if you're studying for IP, that is only the thing which you can study for that part of relation. So IP కూడా ఈ క్వశ్చన్స్ మాత్రమే చదువుకుంటే చాలు, because it is having only the weightage of your 8 marks for this one. There are no 2 mark questions, there are no 4 mark questions from this. Okay?
Okay, sir.
Okay, chalo. Take care beta. Bye.
Bye, sir.
Bye, sir.